Okay. Okay. So I told you before that logarithms are inverse exponential functions, right? So we have lots of properties that we're working with. Um, what properties do we already know? Right? We know the definition of the logarithm, right? Which says that if, I'm sorry, no, it doesn't. It says that log base b, now did I use y or x here? Log base b of x or y? X. Log base b of x equals y if and only if b to the y equals x, right? So we have that. That's our definition of the logarithm. And then the first property that I gave you was that log base b of 1 is equal to 0. And then I gave you the justification for that, right? We learned that log base b of b is equal to 1. We learned that log base b of b to the y is equal to y. And we learned that b to the power of log base b of x is equal to x, right? And then we learned that natural log, right? This was not a property, but we learned that the natural log of x is the same thing as log base e of x, right? I didn't get that far? Okay, now you know. Log base e, right? E is our natural base. So when we say log base e, that's actually natural log. We don't typically say log base e. Log base e is what we call the natural log. Log base e is the natural log. Okay? It's not an actual property, no. Okay? So that extends these properties. Okay, you can write it right next to these, right? So, okay, don't write this down. I'm going to put this here just to justify or explain why the property is what it is. Okay, so don't write down what's in green in your properties list, right? But if we had log base of 1, what would that equal? Log base e of 1. According to our properties, what would that equal? 0, right? Doesn't matter what the base is. Okay, so therefore, I know, because instead of log base e, what are we going to write? Okay, I feel like I've lost you guys, huh? Good timing. All right. Come on in. You get the back corner available there. Okay. Okay, let's back up. Okay, because I feel like I lost you. What we're going to do, now that I just told you that the natural log is log base e of x. Okay, let's look at all of these properties now using log base e instead of log base b. Okay, we're going to use it, look at these same properties, and we're looking at log base e. So if I have log base e of 1, that equals 0. Well, that means I can rewrite this. What can I rewrite log base e as? Hint, 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 hint. What's log base e? Natural log. So that means the natural log of 1, what do you think that equals? 0. The natural log of 1 is log base e. The natural log of 1 is log base e of 1. Okay, give me a thumbs up if you understand what I just said. Okay, let me say it again, right? The natural log, all right, let me rephrase it. Instead of starting with natural log base e of x. That means my base, instead of b, instead of 10, instead of 5, it's e. E is a number. Remember, we learned e is a number. So instead of writing log base e of x, we just write it in shorthand notation as natural log of x. That's just a shorthand notation. So all of these properties that we learned, these 4 properties, they all apply to the natural log because all of these properties can be written as log base e. So log base e of e, what does that equal? 1. Well, instead of writing log base e, what can I write in shorthand notation? Natural log of e. That equals 1. This is probably one of the most important logarithms that you will see. When we're solving logarithmic equations, we're going to see this over and over and over and over again. The natural log of e equals 1. Right, Ava? Okay. Ava, help me out here. How could I rewrite this third property using log base e?
Log base e.
Good. And what does that equal? Y. Okay. Good. Yes.
So what different is it writing the E instead of the B? Why is it any different? If the B is
It's a different base. The B is referring to any base. This is these formulas in white, these are just your general properties. And it applies to any base, right? So we're saying, what I'm doing now is I'm saying, okay, let's pretend that the base is E. So from that, now I'm showing you basically those same properties, but written in the form of natural log.
So E is just more specific.
Right.
Okay.
So now I can write this. So now this property tells me, because remember, natural log base E is the same as natural log, right? So I've got natural log of what? Of E to the Y. What does that equal? Y. Okay. And then look at this property. This is, let's adapt this to log base E. So this would be E to the log base E of X, right? E to the log base E of X. What does that equal? X. Well, let's come up with our natural log property. So this is E to the natural log of X. And what does that equal? X. Natural log is the same, it is a log. It's just a log whose base happens to be E. Okay, yes.
So whenever there's a base e, it's just natural log and you put the x in from whatever value is there. It doesn't matter.
Correct. Correct. So if we saw log base E of 12, we would actually write that as natural log of 12. Okay, because this ln, this means log base E. That's what ln stands for, log base E. Okay. Okay, let's look at some other properties. Because we know that logarithms are inverse exponential properties. So we're going to add one to our list. So number 5 on our list. If I have the log, any base, log base b, of the product of two things. So we're going to say r times s. Now let's just think about exponents. If I have two numbers that have the same base, like x to the 5th times x to the 10th, what do I do with the exponents? Add them, right? Well, our logarithms follow the same type of rule. This can be rewritten as log base b of r plus log base b of s. Okay. Now that applies to natural log also. Okay. So alongside of it, the natural log of r times s, what do you think that's going to equal? The natural log of r plus the natural log of s. Okay. So for instance, let me give you an example here. Let's say that we have the log, okay, log of 8xy to the 4th. We can expand this. Okay, first off, what is the base here? When the base is not written there. The base is assumed to be a 10. If there is no base written there, we assume it to be a 10. We work in base 10 in the United States. Okay, so that's how you can remember it. If it's not there, you can assume it's a 10. Okay, so let's expand this. This is all multiplication. So what do you think we can do with it? Jackie, what do you think we can do with it? Say again? Well, this is all multiplied, right? What does this property up here say we can do when we have two things that are multiplied? Add them. We can add them. So we're going to rewrite this as log 8 plus log x plus log y to the 4th. Okay. Now that leads me to another property. Here's property number 6. I told you there's a lot of properties. That's why we're writing them on a separate piece of paper so that we can quickly refer to them. You'll get quick at this, but initially it's kind of overwhelming. There's a lot. Okay, so for now, you're just going to keep referring to that page that you have with all your properties written on it. Yes?
Before we get too far, so over for the where you said there's the log base 10 when it's assumed, is that in all the added ones?
Yes, yes. I don't have to write that 10. Okay. So here's our next property. Log base b of y to the c. Log base b of y to the c. Now, before I tell you what that's equal to, let's think about what that actually means. Let's look at an example. Actually, I'll use this one as my example, right? Log base or log of y to the 4th. Well, what does y to the 4th mean? Go back to your algebra. What does y to the 4th mean? Y times y times y times y, right? That's what y to the 4th means, Gavin? Okay, What does this property number 5 say I can do with the multiplication? I can add them. So let's rewrite this. Let's rewrite log y plus log y plus log y plus log y. Now that's kind of a pain in the neck, isn't it? To write log y plus log y plus log y. Okay, refer back to what you know about math. Is there another way of writing that? Instead of writing x plus x plus x plus x, what would you write? Huh? That would be if it was x times x times x times x. What if it's just x plus x plus x plus x? 4x. It's 4x. So what would this be? Log y plus, what is it? 4 log y. 4 log y. What did we just discover? Log y to the 4th can be written as 4 log y. Right? So finish this property for me. Log base b of y to the power of c. How could I rewrite that? What did we do with this exponent here? What did we do with that? We moved it to the front, didn't we? What can we do with this exponent here? Move it to the front. So this is c times log base b of y. Okay, so we just learned 2 new properties. One says that when we're multiplying, we can separate them into separate logs and add them together. The other one says that when we have a function to a power, we can move that power in front. Okay? Okay, we're going to keep learning some new properties. All of these properties, we're just learning the rules basically. We're learning the rules so that we can apply them later to solve some application problems, like those half-life problems that we were working on earlier this year. Okay? So let's do some more rules. See you, Charlie. Okay, so if multiplying means that we can add the logarithms, what do you think happens when we divide? We're going to subtract them. So log base b of r divided by s can be rewritten as log base b of r divided by log base b of s. Bless you. Now, of course, this applies to our natural logs also. All of these rules apply to our natural logs, right? The natural log of y to the power of c is equal to c times the natural log of y. Here we got the natural log of r over s can be rewritten as, oops, what did I do? Oh, I made a mistake. Holy cow. I'm sorry. I made a big goof. Natural log of r minus the log of s. I'm so sorry. I didn't even notice it until I started to write the natural log one. Division means subtraction. Natural log of r minus the natural log of s. Okay. Okay. Let me see. Power rule, quotient rule, product rule. Okay. So what we're going to do is we are going to use these properties to expand and condense some logarithms. Okay? So I'm going to work through these problems with you. Okay, so let's take the natural log of 8x. Okay, natural log of 8x. And I want to expand this. So I'm going to use the properties that I just learned and expand it. Okay? So I've got the natural log. Now that ln just means it's log base e, right? So I'm not going to get worried about the ln. I'm just going to apply the properties we learned. What do our properties say we can do when we have multiplication? Change it to addition. So this is the natural log of 8 plus the natural log of x, and we're done. It's expanded. Yeah.
So for the natural log, is it an L then or an
L. ln. Okay, and it's not an uppercase, it's a lowercase l. Okay, how about the next one? Log of 3 over x. Now there's no base there. What does that mean? Base 10, right. Okay, let's expand this. This is division. So what do we do with that division? Subtraction. Log 3 minus log x. Okay. Next one, log x to the 4th. Log x to the 4th. What do you think? Yes.
4
Good. 4 times log x. Right? Okay, I'm getting a little bit harder. Log x to the 3rd y squared. Log x to the 3rd y squared. So this one's a little bit harder. So let's walk through this. I can't move the 3 in front yet because that 3 does not apply to both the x and the y. So what do you think I could do first? Yeah, change it into addition. This will be log x to the 3rd plus log y to the 2nd. Okay. Then what? Yeah. Move the exponents to the front. Yes, so this is 3 log x plus 2 log y. Okay. Try number 5 on your own. Okay, so let's say this is going to be log x squared minus log y squared, which I can then change to 2 log x minus 2 log y. Now there is another way of doing this problem. So I'm going to show you an equivalent answer. If I were to rewrite it first as log x over y squared, right? X over y squared is equivalent to x squared over y squared. For this one, now I can move the 2 in front first, like that, and then deal with the division. So if I did that, it's 2 times log x divided by 5. So I'd have to put it in parentheses like this. Okay. These are equivalent answers, right? If I distributed that 2, it'd have 2 log x minus 2 log y. Okay. Okay, number 6, not last one, number 6. So we've got log base 3 of x, y to the third. Okay, so let's separate these. Log base 3 of x plus log base 3 of y to the third. And then what? Log base 3 of x plus 3 log base 3 of y. And we're done. Questions on expanding? We're going to do some harder ones, but let's finish this worksheet first. Okay, the bottom part of the worksheet, 7 through 10, we're going the opposite direction. We're going to try to condense them. Okay, we're going to condense them. So number 7, I have the natural log of x plus the natural log of 5. So what goes with the addition? Multiplication. So how would I rewrite this? Natural log of 5x, or x times 5, right? Okay, next one, 2 log x plus 3 log y. Just like your order of operations, do your exponents first. So let's rewrite this. Where did that 2 come from? Well, that was an exponent. So log x squared plus log y to the third, which we know is multiplication. So this is log x squared y to the third. Is this making sense? Okay. Okay. For natural log of xy minus 3 natural log of yz. Okay, what can we do with that one? Mika? Okay, so I have to do, okay, we'll do the division first. That's fine. So how would I write that? Okay, so since the xy is in parentheses, I can rewrite it as natural log of xy to the fourth minus natural log of yz to the third. And then we can change it into division. Natural log of xy to the fourth divided by yz to the third. Okay. By the way, that is not the same as natural log of xy to the fourth divided by natural log of yz to the third. They are not the same. Okay? They're not the same. You cannot put if the natural log's on both the top and the bottom, it's a whole different thing. It's like if I said log base 3 of 27 divided by 3, right? That is very different, right? So this would be the natural log of, log base 3 of 9, and we know log base 3 of 9 is 2, right? Well, if I did log base 3 of 27 divided by log base 3 of 3, log base 3 of 27 is 3, log base 3 of 3 is 1, I get 3. They're not equivalent, right? So you can't take this and separate it into two logarithms, okay? However, notice, let's use our properties, right? Our properties of logarithms says that I can take this log base 3 of 27 over 3 and rewrite it as log base 3 of 27 minus log base 3 of 3. What's the log base 3 of 27? 3. What's the log base 3 of 3? 1. 3 minus 1 is 2, and that's what I know that equals. Okay, so you see how they work? Okay, let's look at number 10. So we have 3 natural log of x to the third y plus 2 natural log of yz squared. Okay. What are we going to do? Caleb, what are we going to do? Good.
Natural log of yz squared 2.
Good. Okay. All right. Ariel, what now?
Divide them, you get natural log of this is x to the third y all raised to the third divided by
It's addition
you
times, right?
yeah.
Okay. So, because I have a y in both of these, I'm going to have to go ahead and distribute those exponents a little bit so I can combine my y's. Okay. So, natural log of x, remember when you have the exponent outside, we distribute it. So, x to the ninth, y to the third, times y squared z to the fourth. Right, just using my properties of exponents. Now I can go ahead and combine those y's. So this is the natural log of x to the ninth, y to the fifth, z to the fourth. And that's going to be my final answer there. Okay. Yeah.
There were 2 ways in the previous one, but it's division, so we can
We could have. I missed that. Thank you. So this one, what could we do with this? Let's see. This is natural log of x to the fourth, y to the fourth over y to the third, z to the third, right? So that's going to simplify to natural log x to the fourth, y over z to the third. Good observation. Okay. Mm-hmm.
If we don't do that, is it wrong?
It's incomplete, yeah. Okay. We're going to look at a harder one. This one's really hard. Ready? Yes, yes. Okay, I have the natural log of the square root of x squared plus 5 over x. Let's expand this one. Let's expand this. Any thoughts? Yeah. Subtraction. Okay. So let's do natural log of the square root of x squared plus 5 minus the natural log of x. Okay. What do you think? Can I rewrite the square root? How could we rewrite square roots?
To the power of 1 half.
To the power of 1/2. Let's do that. Natural log x squared plus 5 to the power of 1/2 minus the natural log of x. Okay, now maybe we can go somewhere. What do you think? What can I do now? Put the 1/2 in front. 1/2 natural log x squared plus 5 minus natural log of x. And that's all we can do. Okay? Okay, here's another condensing one. I'm going to have you do this yourself. I want you to condense natural log of x to the 5th minus 2 natural log of x y. I want you to condense this into a single logarithm. Condense it into a single logarithm. All right, what's our first step here? Morgan, what did you do first?
ln x to the 5th divided by 2 ln xy.
You got the right idea. The subtraction, that's the right idea. Anyone do something different? Kaylin?
I moved the 2 to the exponent of xy.
Yeah, let's move that 2 to the exponent first. Okay, so let's move the 2 to the exponent first. Then what? Allie, what did you do next?
I didn't get that far.
Okay. Jordan?
Make it like 5 natural log x.
Well, we're trying to condense it into one smaller instead of going the other way.
Divide them.
Yes. So what are we going to do when we divide?
Natural log 5x.
Natural log of x to the 5th.
Yeah. Over natural log.
Nope. Nope, you're close. You're close. Mika?
Over x squared.
Right. Remember, we just talked about this, right? We don't rewrite the logarithm. Do I still have it up there? I probably erased it, didn't I? Remember this example here, right? This is not equivalent to log 27 over log 3. Right? It's just the number that we're changing. Okay? It's just the number we're dividing. Okay, but we have to go further with this, don't we? Yes. So let's see. Natural log of x to the 5th over x squared y squared, which gives us natural log of x to the 3rd over y squared, okay? So when we do the division, it's just the terms in front that we're dividing. We're not dividing the natural log over natural log, okay? It's just the terms in front that we are dividing. Okay. I have a practice worksheet for you for homework. I'm going to make a place for you to upload your classwork that we just did and the homework, okay? I will not be here on Friday. Is that when we have class again? I have a meeting that'll be off campus all day. So I will have a video recording where I'll go over the homework and then you'll have additional, I'm sorry. Yeah. Okay, I have to change I originally had planned a quiz on Friday, but I don't feel like we're ready for it yet. So I'll go over the homework and then I'll have additional work for you to do, okay? There will not be a homework mini quiz because I won't be here, okay? So I will go over this homework and then I'll have another lesson on the video. I need somebody to be in charge of projecting the video up front. Who wants to do that? Who knows they're absolutely going to do it Friday and is comfortable doing that? Okay, Gavin, I'm going to rely on you. You're going to be here Friday?
Probably.
Okay. All right. Caitlin, you feel comfortable?
Yeah.
Okay. Whew, yeah.